Chapter 1, Section 4, Integers and Absolute Value. You can see there are a lot of I can statements in this one. We'll start with I can locate integers on a number line. Second one, I can identify a number and its opposite. Third one, I can compare integers using less than, greater than, equal to, less than or equal to, or greater than or equal to. Fourth one, I can find absolute value of a number using a number line. Fifth one, I can write absolute value notation. And the final one, I can explain the relationship between distance on a number line and absolute value. Vocabulary that you maybe noticed in those I can statements would be integer, opposite, additive inverse, and absolute value. Integers are the set of whole numbers and their opposites. For example, 1, 2, 3, 4, and along with that, -1, -2, -3, -4. And of course, when we're talking about whole numbers, that does include 0. Opposites and additive inverses really are the same. They're numbers that are the same distance from 0, but on opposite sides of 0. So, for example, the opposite of 3 is -3. On the symbol chart, I'd like you to fill in what each one stands for. The top left corner is less than. The top right corner, greater than. The bottom left corner, equal to. And the bottom right corner is a brand new one, absolute value. First, we want to start by understanding the order of numbers when we're talking positives and negatives. So if we have the numbers -4, 2, 5, and -3, we want to order them least to greatest. We would start with the negatives. The largest as a whole number would be the smallest as a negative. So we would start with -4, -3, 2, and 5. Now we want to compare positive and negative numbers using either less than, greater than, or equal to. If Fran's score is -2 and Joaquin's score is -3, how would we compare -2 with -3? Well, if you think about money, if you lose $2 or you lose $3, it's better to only lose 2 than it is to lose 3. So we would say that -2 is greater than -3. If you look at the number line, you can see that -2 is one step closer to 0, making it the larger number. You'll also notice that it doesn't have to be written with the -2 first. If we put the -3 in front, it's -3 is less than -2, and the sign reverses. Let's find the additive inverse, which we said is the same as the opposite of each integer. If the number is 6, the additive inverse or opposite is -6. If the number is -14, the opposite is +14. And we can do the same with decimals. If it's 0.5, the opposite is -0.5. Here's the new stuff, absolute value. If you remember, one thing about absolute value is that it is a distance. And if you think about walking or running or anything that involves distance, distance is always positive. So you can run a mile, and even if you ran the mile backwards, you would still be traveling a positive distance. We don't say that we walked -1 mile. We would say we walked 1 mile. So the distance that we find absolute value with is from 0. So if you picture a number line, 0 is always your center point. So the absolute value of -4 would be 4 spots away from 0. Absolute value is recognized by the 2 straight lines on either side of the operation or number. What you'll also notice is that the absolute value of +4 is 4. So additive inverses have the same absolute value. So let's simplify a couple of these. When we do these, if there's absolute value bars, we treat them as if they are parentheses by doing them first. So we would start with the absolute value of -8, which would be +8. Then we would do the absolute value of -5, which would be +5. Now we add the two together, which would be 8 plus 5, which is 13. In example B, because we treat the absolute value signs like parentheses, we would start by doing 5 minus 6 and to get -1. But the absolute value bars are still there. Now we take the absolute value of -1, and that gives us an answer of +1. Let's try a couple more. The absolute value of -2 would be 2. The absolute value of 9 would be 9. 2 plus 9 is 11. So even if the number in the inside of the absolute value bars is positive, it's still positive. It comes out of those absolute value bars the same number. In example B, we have 1 minus 1, which is 0, and the absolute value of 0 is 0 because 0 is no steps away from 0. What you'll notice in this last one is that the negative sign is in front of the absolute value. If you ignore that negative sign, you have to first do the absolute value of 5, which is 5, and then the negative sign stays in front. So the absolute value of 5 with the negative in front of it would be -5. It's like taking the absolute value times -1, and that's all there is to it.